What happens when a country tries to build a fighter that can compete with the most advanced aircraft in the world? The result is the Sukhoi Su-57, Russia's first operational fifth-generation fighter. With its combination of low observable design, supersonic speed, advanced avionics, internal weapons bays, and remarkable maneuverability, the Su-57 has become one of the most closely watched fighter aircraft of the modern era. But the story of the Su-57 is not simply about speed and technology. Its development took decades. Its design went through major changes, and the aircraft has faced both technical challenges and delays. So how was the Su-57 developed? What makes it different from other modern fighters? And what does the future hold for this unusual aircraft? Let's take a closer look. The story of the Su-57 begins in the 1990s. After the collapse of the Soviet Union, Russia's aviation industry faced major financial and technological difficulties. However, Russian aerospace designers still wanted to develop a new generation of fighter aircraft that could eventually replace older platforms such as the Su-27 and MiG-29. The program that eventually produced the Su-57 was initially known as the PAK-FA, which stood for a Russian term describing a future frontline aviation complex. The project was led by Sukhoi. The objective was ambitious: create a fighter with advanced sensors, high maneuverability, long range, supersonic performance, and reduced radar visibility. After years of development, the first prototype finally took to the air in January 2010. This was a major milestone. The aircraft was initially known as the T-50, referring to its prototype designation. Over the following years, multiple prototypes were constructed and tested as engineers continued refining the design. At first glance, the Su-57 looks very different from earlier Sukhoi fighters. Traditional Sukhoi aircraft, such as the Su-27 and Su-30, are famous for their large, curved aerodynamic surfaces and powerful engines. The Su-57 retains some of that family resemblance, but its design incorporates much stronger emphasis on reducing radar visibility. Its fuselage contains carefully angled surfaces. The engines are positioned with the goal of reducing their exposure from certain directions. Weapons can be carried inside internal bays, rather than always being mounted externally. This is important because external weapons and fuel tanks can increase an aircraft's radar signature. The Su-57 also uses advanced materials and coatings intended to further reduce detectability. However, stealth is not the only priority. Unlike some other fifth-generation fighters, the Su-57 places considerable emphasis on aerodynamic performance and maneuverability. Its large leading-edge surfaces, movable control surfaces, and powerful engines give it impressive agility. The result is an aircraft designed to balance stealth with traditional Russian fighter characteristics. One of the most interesting aspects of the Su-57 is its propulsion system. Early Su-57 prototypes were powered by the AL-41F1 engine. This engine provided substantial thrust and allowed the aircraft to demonstrate impressive performance during testing. However, Russia has also been developing a new engine specifically intended for the Su-57. This engine is commonly referred to as the Izdalia 30, meaning Product 30. The new engine is designed to provide greater efficiency, improved performance, and potentially a higher thrust-to-weight ratio. It is also intended to improve the aircraft's ability to cruise at supersonic speeds without relying continuously on afterburners. This capability is known as supercruise. Supercruise is valuable because it can allow a fighter to travel at supersonic speed without consuming fuel as rapidly as it would while using afterburners. However, development of the new engine has taken time, and aircraft equipped with earlier engines have continued to form an important part of the program. If there's one characteristic that immediately stands out when watching the Su-57 fly, it is maneuverability. The aircraft is capable of performing dramatic, high angle of attack maneuvers. Part of this capability comes from its aerodynamic design. Another important feature is thrust. Thrust vectoring systems allow the direction of engine exhaust to be adjusted. This gives the aircraft additional control authority, particularly during extreme maneuvers. At air shows and demonstrations, the Su-57 has performed impressive turns, climbs, and other high-alpha maneuvers. However, modern air combat is not simply about performing spectacular maneuvers beyond visual range sensors. Missiles, electronic warfare, communications, and situational awareness are all extremely important. This is why the Su-57's designers have focused heavily on combining maneuverability with advanced electronics. A modern fighter is essentially a flying computer. The pilot needs information about aircraft, terrain, weapons, threats, and friendly forces, all while traveling at hundreds of kilometers per hour. The Su-57 therefore incorporates an extensive collection of sensors. One of the most important is its radar system. The aircraft is associated with the N036 Bielka radar family, which uses electronically scanned arrays. The system is designed to provide the aircraft with a broad picture of its surroundings. The Su-57 also incorporates other sensors that can help detect and track targets. One notable feature is its distributed electro-optical and infrared sensing equipment. These systems can provide information without relying exclusively on radar. This is particularly important because radar emissions can potentially reveal an aircraft's location. By combining different sensors, the Su-57 is intended to give its pilot a more complete picture of the battle space. Another major feature of the Su-57 is its internal weapons storage, 5th generation. Fighters generally try to carry important weapons inside the aircraft whenever possible. The reason is simple: weapons mounted externally create additional radar reflections. By storing them internally, the aircraft can maintain a cleaner aerodynamic and radar profile. The Su-57 has internal weapon bays designed to carry a variety of air-to-air and air-to-surface weapons. It also has external hardpoints that can be used when stealth is less important or when additional payload is required. This gives the aircraft flexibility depending on the mission. The Su-57 has also been associated with several modern Russian missiles and precision-guided weapons. Its internal and external weapon options allow it to perform both air combat and strike missions. After years of development and testing, the Su-57 finally entered Russian military service in the early 2020s. The first operational aircraft represented an important milestone for Russia's aerospace industry. However, production has remained relatively limited compared with some older Russian fighter families. The aircraft has also continued to receive upgrades. As with many modern fighter programs, development does not simply stop once an aircraft enters service. New software, sensors, weapons, engines, and other technologies can continue to be introduced throughout the aircraft's lifetime. Russia has also promoted the Su-57 internationally, hoping to attract foreign customers. However, international sales have been more limited than originally hoped. The Su-57 has reportedly been used in operational conditions, including missions associated with Russia's war in Ukraine. Russian officials have claimed that the aircraft has been used for a variety of missions. However, publicly available information about the aircraft's exact operational activities is limited, and many claims cannot be independently verified. What can be said with greater confidence is that operational experience provides valuable information for engineers. Real-world missions can reveal weaknesses and opportunities for improvement that may not appear during normal testing. The aircraft's future development will likely depend partly on lessons learned from operational use. The Su-57 is often compared with aircraft such as the American F-22 Raptor and F-35 Lightning. Agree, all three aircraft incorporate fifth-generation technologies, but their design philosophies are not identical. The F-22 places a very strong emphasis on air superiority, stealth, speed, and maneuverability. The F-35 emphasizes stealth, sensor fusion, networking, and multi-role operations. The Su-57 combines reduced radar visibility with long range, high maneuverability, speed, and a broad weapons and sensor suite. Rather than simply copying the design philosophy of another country, Russian engineers developed their own approach. The question of which aircraft is best is difficult to answer because actual effectiveness depends on factors such as training, support systems, sensors, weapons, mission type, and the wider military network surrounding the aircraft. So what comes next for the Su-57? Future improvements are expected to focus on areas such as propulsion, avionics, sensors, weapons, and production. The new generation engine remains an important part of the aircraft's development. Russia is also working toward expanding production and continuing modernization. Whether the Su-57 eventually becomes a large-scale fighter fleet or remains a relatively limited aircraft, it has already secured an important place in modern aviation history. It represents decades of Russian aerospace development and an attempt to create a fight